Amazing people. Here's another example of dealing with annuities. So an amount of $50 is put into an investment account at the end of each month. If interest is paid at 12% per annum, paid monthly, how much is in the account at the end of the 10th year? So first of all, pay key attention to this. It's at the end of each month that the amount is put in. So that means for the first $50 put in that first month, it does not earn interest. That's going to apply to all of those amounts. So let's start to break this down into each of the contributions that we've got. So we've got the first contribution. This is going to be $50 times 1.01 to the power of 120 minus 1. So that's going to be to the power of 119. Okay, let's work out our second contribution. So similar to this, A2 is going to be equal to $50 times 1.01. And that's going to be to the power of 118 because it's 119 months minus that one. All right, and moving on to the third contribution. In this case, we're going to have this is equal to $50 times 1.01. That's going to be to the power of 117. Now, we're going to jump ahead here to the last contribution. So this is the 120th contribution. Okay, this one is going to be equal to $50 times 1.01, but because it's put in at the very end, it's actually going to have 0 periods of interest earned here. So that's going to be the value of it. Now, what we're going to do is start to calculate what our future value is, using this to help us establish the pattern and equations. So our future value is going to be equal to A1 plus A2 plus A3 plus ... all the way up to 120, which we need to include here. Now, if we start to make these substitutions in, we've got 50 times 1.01 to the power of 119 plus 50 times 1.01 to the power of 118 plus 50 times 1.01 to the power of 117 plus ... up to 50 times 1.01 to the power of 0 in this case. So now what I'm going to do is I want to factorize this before I do anything else. So I'm going to have 1.01 to the power of 119. Actually, let's write that better. Don't need the brackets now. To the power of 119 plus 1.01 to the power of 118, 1.01 to the power of 117, all the way up to 1.01 to the power of 0 here. Now, as I keep going again, I'm going to rearrange this so it's in a better order for me. So I'm going to start with 1.001 to the power of 0, plus 1.01 to the power of 1, plus 1.01 power of 2, all the way up to 1.01 to the power of 119 in this case. So from here now, we can start to work all the different elements out by using the sum of a geometric series. So in this case here, we're going to have sum to 120. That's going to be equal to 1. Bracket 1.01. This is to the power of 120 minus 1 all over 1.01 minus 1 in brackets. And so when we work this out, we have $230.04. This is rounded to 2 decimal places. Remember, this is only an approximation because of that rounding, but it's close enough for what we're doing now. And this is going to be 50 times 230.04. And when we work this out, what we end up with is $11,501.94.